So, what is a binomial? First of all, a binomial is defined as a polynomial with two terms. So, let's just write that down. A binomial is a polynomial with two terms. And we're going to define each of these separate words. So what is a polynomial? A polynomial is any sequence of terms, and I'll define what a term is later. A polynomial is any amount of terms that are separated by addition or subtraction. So what is a term? A term is, okay, so let's say a polynomial, let's write that down. A polynomial is a combination of two or more terms separated by addition or subtraction. Alright, and what is a term? A term is any arithmetic sequence, arithmetic term or expression in which the variables or constants are separated by multiplication or division. For example, a term would be 3x, or say m would also be a term, or say just 3 by itself, that would also be a term, and so forth. So we can see that something that is not a term, so I'm just going to separate these two for clarification purposes. So not a term, for example, 3x plus 1. That's not a term. That is a binomial because it has two terms. Two terms. 1, 2. And they're separated by an addition sign. Or we can also do two variables that are separated by a subtraction sign. So, for example, that'd be like 2x minus 3. This, once again, is a binomial because there are two terms. 1, 2. And they're separated by a subtraction sign. So these two terms, there's two terms, right? And bi in Latin means two. So thus, since it has two terms, it's called a binomial. Alright, let's progress with the actual work. So basically, I'm just going to use a new sheet of paper. Basically, a binomial. Say, let's take for example, x plus 3 to the power of 2. Now this is quite a simple binomial, and you can probably just solve this without any special tricks. You just know that x plus 3 squared. Let's talk about the basics on how to solve this. The basics. Right, so x plus 3 squared. This can be written as x plus 3 times x plus 3. As you know, any term squared is equal to itself multiplied by itself. Alright, so x plus 3 times x plus 3. And most of the time people like to expand this even more by using something called the distributive property. And how the distributive property works. Distributive property. And how this distributive property works is basically there's an acronym that you would use, and it's called FOIL. FOIL. And what FOIL stands for is first, outer, inner, last. While these terms may not immediately become apparent, what these terms mean is, first means, say we have our example over here, x plus 3, example, x plus 3. Alright, so first, what that means is, this is the first variable of the first term, right? So we're going to select that, and this is the first variable of the second term. First basically means the two first terms. So you multiply these two together, which hence you get x squared, which is the first term. Vice versa, this would also work for division, in which case, say you had x plus 3 over x plus 3, that would be quite similar, except for you would be dividing. Alright, just so I don't confuse any of you, I'm just going to cross this out. Alright, so once you get the x squared, you would put, you would do the next operation, which is outer. Alright, so for outer, oh, oops, add an extra t there. There's an extra t there. Alright, that's really messy. Alright. I should probably rewrite that. I'm going to do that. Outer is supposed to be right here. Alright. Cross that out. Outer. Alright. So outer means you would then multiply together the two outer terms, which is 3 and 3. And now you would multiply these two together. And what you get there would be multiply, and what you would get there would you would get 9. So you would add 9 to the very end, adding a bit of a space. Oh, sorry, 3 times 3 is actually last. Outer would simply mean x times 3, the two outer variables. X and 3, see, they're on the outside of this whole polynomial. So you would multiply these two together. Now these lines are a bit confusing. So you would add 3x, and this is also surprisingly 3x. And these two terms, as you can see, are the inner terms. They're towards the inside of the entire term. And you can see this constitute the inner part of the acronym. So you multiply these two together, the two inners together, and you get plus 3x. Alright, and you add 3x, and now what do you do? That is your final thing. That is your final answer. But then you notice that there's two like terms here. And what like terms are? They're two terms with the same variable, and they can be added together. So for simplicity's sake, we're going to add them together. Equals x squared plus 6x plus 9. That is your final variable. Alright, now we're going to think about what we would do if there was more than this simple equation. Since this is a relatively simple equation, it only requires you to expand these two, but we find that this will be exceedingly difficult the larger this number over here is. For example, it's 6. That would be illogical to actually expand the entire equation. So, which is why we will be using a nifty trick I will show you in order to speed up this process in case you're ever doing this question on a test. Alright, so the first thing I will be doing is I will be showing you how to do this. But first I have to show you something. It's called Pascal's triangle. In a bit of history, you might know about Pascal's triangle. It was invented by Blaise Pascal, and it is a fundamental mathematic concept that is very useful in math. As you can see, there are many intricate patterns within the triangle. As you can see, the triangle starts off with 1, 1, 1 written like this. And these are the first two layers, or the first two layers of the pyramid, the top two layers of the pyramid. Next, you would find the sum of these two numbers in order to make the next, and you put ones on the edges, and then you fill these two. 1 plus 2 is 3, 1 plus 2 plus 1 is 3. You continue that down, and there's 1, that's 4, that's 6, 4, 1. 1, 1 plus 4, 5, 4 plus 6, 10, 6 plus 4, 10, 1 plus 4 plus 1, 5, and 1. This is the first layer. This is the first actual layer. This is second actual layer, third actual layer, fourth actual layer, fifth actual layer. And as you can see, this will continue to go down. Alright, I'm going to move the sheet up a bit. 1, 6, 15, 20, 10, 10 plus 10, 10 plus 5, 15, 5 plus 1, 6, and 1. This is the sixth actual layer of the triangle. 1, 7, what's 6 plus 5? That's 21. 20 plus 15, that's 35. 20 plus 15, that is 35. 15 plus 6, that is 21. 6 plus 1, that is 7, and 1. This, we can see, is the seventh actual layer of our word triangle. Alright, so you can see these are the fundamental layers of the triangle, and they continue on following that pattern that I have shown you. Alright, so as you can see, you may have noticed a pattern, and this pattern is, since this variable, you know that 1 is the coefficient of x here. So if we draw an imaginary version of, so if you draw in the imaginary one, I will show you how to do this. So let's assume that both variables in the binomial power, in the binomial to the exponent of something, we'll assume that both terms are variables, which will make it easier to illustrate this point. So let's take, for example, a plus b squared. Alright, what's that equal to? It's equal to a plus b times a plus b. Alright, as you have seen from before, this would equal a times a, which is inner. You can see first right here. So first times first is a squared. Next, you add b times a, which is the, you would add a times b, which is the outer. So a times b, that's ab. And then next you do inner, right here. So b and a, I forgot to draw these lines. So b and a, that is ba. And lastly, you do last. So b times b plus b squared equals a squared, and I'm just going to simplify this, so you know that BA equals AB, plus 2AB, right? Because if this is AB, then AB plus AB, that would be 2AB, plus B squared. As you can see, we're just going to add in the coefficients to all the variables, just to make this more clear. 1A squared, right? Plus 2AB, plus 1b squared. Do you notice anything about these? Look over at the Pascal's triangle. If you look at the second one, this is to the power 2, right? Now look here on the second actual level, and you notice 1, 2, 1. Notice the pattern? 1, 2, 1. These numbers are the coefficients of the simplified polynomial of this power. So applying this rule, let's try a plus b to the power of 3. Alright? A plus b, bracket that whole thing, to the power of 3. As we know, this equals a plus b times a plus b times a plus b, and multiply together. That gives a very long equation. You could always solve it by doing a plus b times a squared plus ab plus ba plus b squared, which is this part, and as we know, this part is equal to this part. So if we do this part, it is equal to this part, right? But this method takes a lot longer. But what we are going to do is we are going to use this nifty trick. So write 1 blank, and since you know that this is a plus sign, we're going to write plus. Since all this is a plus sign, we are allowed to write plus. And next we write 3, which is the coefficient of the second variable. 3 plus 3 again. And we add a 1 blank. As you can see, this corresponds to 1, 3, 3, 1, 1, 3, 3, 1. As you can see, this is a third layer, and this is to the power of 3. Alright, so what we're going to do first is I'm going to establish a structure. So a to the power of 3 is what a times a times a times a is. So what you would do first is you raise the first variable to the power of this exponent right here. So that'd be a to the power of 3. And you multiply that by b to the power of 3 minus this variable that a has, which is 3, right? So that'd be times b to the power of 0. And next we would do 3. Alright, so every time we progress through this, the exponent for a will get 1 less than the previous one. So here it would be a to the power of 2. But since the exponent for b up here is equal b to the power of x, where x is equal to 3 minus the exponent minus the exponent of a. And this 3 just comes from here. If it was 4, that'd be 4 minus the exponent of a. If it was 5, that'd be 5 minus the exponent of a. Sorry. Alright, and now we know 3 minus 2 is 1, so b to the power of 1. Then plus 3, we know that a decreases, the exponent of a decreases by 1, so a to the power of 1, right? 2 minus 1, and we add 1 to b, right? Because like 3 minus 1 is 2, so b to the power of 2. And for this last and final one, a to the power of 1, okay, so 1 minus 1 is 0, so a to the power of 0, and then 3 minus 0 is 3, so b to the power of 3. And there we have it, is the final answer. But we have to simplify this. As we can see, to make it more visually appealing, we're going to take out the 1, right? Because like, you know that 1 multiplied by any variable is just itself. So we're going to take out the 1 here. We're going to take out b to the power of 0 because we know that's 1, right? So we know that this is equal to a power 3 plus 3a squared b plus 3ab squared plus b cubed, right? A to the power of 0 is 1. And that here is our final answer. This guy right here. Alright, so I'm going to try with another example just to make sure that you understand this concept. Alright, so for this concept, I'm just going to do a practice problem. Feel free to pause the video so that you can try out these practice problems. A plus b to the power of 5. That's number 1. A plus b to the power of 5. Feel free to pause the video and do the problem, and I'll be here when you come back. Alright. So now I'll give you the solution once you have tried this problem or attempted it. So basically you know that this is equal to a plus b times a plus b times a plus b times a plus b times a plus b. There's a total of 5 of these. 1, 2, 3, 4, 5 of these small groups, corresponding to the 5 up here, right? And now if we look back to Pascal's triangle, we remember that the numbers are the numbers for the 5th row, which is the exponent here, number 5, right? We find that the 5th row is 1, 5, 10, 10, 5, 1. So I'm just going to write that over here. 1, 5, 10. I'm going to put commas to separate them. 1, 5, 10. 10, 5, 1. Can you see that? Sorry, it's a bit off the screen. 10, 5, 1. Yep, that's right. Alright. So flip this over. Alright. So following a similar pattern to the one we did last time. Alright, so following a similar pattern to the one we did last time, I'm going to do equals 1 blank, right? There's the 1 right there, first digit, plus 5 blank, plus 10 blank, plus 10 blank, plus 5 blank, plus 1 blank, right? And next we're going to fill in the variables. So you know that first you're going to make a to the power of 5. A is going to start at this first variable is always going to start at the power of this number here. So in all cases, a is going to be to the power of 5. And as you know, the coefficient of b is equal to the coefficient, the exponent of b is going to be equal to 5 minus the exponent of a, of this number here. 5 minus this number, right? And we know that that's 0, so b to the power of 0. And next, you know, a decreases, the exponent of a decreases by 1, so a to the power of 4. B is equal to 5 minus this 4 right here, so b to the power of 1. A, you know, is to the power of 3 because it decreases by 1. And b to the power of 2. I'm just going to speed through this because you understand the concept. Don't want to spend too much time on this. Just make sure that you understand this piece of knowledge. It's a 4. That's a 4. And a b to the power of 5. A to the power of 0, sorry. Alright, so that is the final, equation. But, of course, we have to take out these unnecessary ones and the unnecessary b to the power of 0s to make it more visually appealing, sorry. Equals a to the power of 5 plus 5 to the power times a to the power of 4 times b to the power of 1, which is just b, right? B to the power of 1 is b, right? Plus 10 times a to the power of 3 times b to the power of 2 plus 10 times a to the power of 2 times b to the power of 3 and plus 5 times a, we know that a1 is equal to a, right? Times b to the power of 4 plus 1 times, we know a to the power of 0 is 1 plus plus b to the power of 5, right? Because we know that 1 multiplied by any number is equal to that number, right? Alright, so here's the final simplified answer. And you'll find that if you do have the time to expand this, you'll see that you will get the exact same answer from expanding this equation here as you will from this final answer here. And I'm just going to box that answer to show that it is the final answer. Alright, and just before we leave, I'm just going to do one more problem. Now this is going to be a different type of problem. Here we've seen a plus b to the power of 5, right? Sorry, that 5 is a bit obscured by the circling I've done there. Alright, so a plus b to the power of 5. So far all of our examples have had a plus here. Now you may be wondering, what would happen if we had a minus or subtraction sign there? So let's do that example right now. Let's just do a minus 5 to the power of, say, 3, right? And I'm just going to use a constant this time because we've been using variables for both terms for quite a few examples. And I'd just like to illustrate how this would look if we had one constant here. Alright, so this would expand to a minus 5 times a minus 5 times a minus 5, right? So you could always factor this out. It's relatively small. You could just do a minus 5 times a minus 5, multiply this together, and then multiply that by a minus 5. But I'm being confusing. Let's just focus on the way that this shortcut way. Alright, so as we might remember, the Pascal's triangle layer for the third actual layer here is 1, 3, 3, 1. I'm just going to write that on the side. 1, 3, 3, 1, so we don't forget. Alright, so as always, 1 here, alright? And I'm just going to omit the sign. I'll put like a tiny line here, not to be confused with the subtraction sign. Actually, I'll make it a box. That'll make it less confusing. Alright, so this stands for where the sign should go. Alright, and then the next term is 3, right? So 3, this, blank. We're doing another box, right? These subtraction things are pretty mysterious, aren't they? 3, another 3, and a box and 1, right? Alright, so we have quite the standard layout. Alright, so as always, we're going to do a to the power of 3 times 5 to the power of 5 to the power of 0, right? Because 3 minus 3 is 0. As always, we're just going to continue as if this was a plus sign. We're just not going to fill out the signs yet, alright? You'll see. Alright, so continuing on. Alright, so we have to find the sign here. And what is that sign here? Alright, so continuing on. We left off where we had to finish, we had to fill in these signs. Alright, so for these signs, what you're going to remember is the last one is always going to be a negative number. It's always going to be a negative sign, alright? And following that, we're just going to alternate patterns, negative, positive, negative, positive, negative, positive, or, sorry, addition, subtraction, addition, subtraction, addition, subtraction, right? This is a subtraction sign. So next I'll do an addition sign and a subtraction sign. Alright, and so to continue, this negative sign here, alright, as we recall from before, it's negative, positive, negative, alternating, right? It's alternating. Alright, so next we're just going to simplify, so that's going to be a to the power of 3 times nothing, right? Because 5 to the power of 0 is just indeed 1, right? And we remember that there is a subtraction sign there. 3 times a to the power of 2, right, from here, times 5, right? And just recall that by not writing anything. I just mean multiplication, right? And addition, 3 plus 3a to the power of 1 times 5 to the power of 2. This looks kind of awkward, so I'm going to add in a multiplication sign right there, right? And I'm just going to subtract 1. Oh, that's already implied, sorry. 5 to the power of 3, right? And to follow even proper form, I could simplify these two variables. Since they're both variables, since they're both constants, I can just simplify out these constants, and I'm just going to simplify this term here and turn it into an actual number without exponents, in which cases this is equal to 5. Sorry, just this one thing is equal to 5 to the power of 3 is equal to 5 times 5 times 5, right? 5 to the power of 3, right? And this thing is equal to 125, right? This we see 3 times 5 is 15, right? 15a squared. 3 times 5 squared is, so 3 times 5 squared, right? 5 squared is 25 equals 3 times 25 equals 75, right? Equal sign. Alright, so we're just gonna draw this into the final answer. So a cubed, that's pretty simple. Minus 15 a squared plus 75a minus 125, right? These are the things that we're writing here, right? And this, right? Right, alright, and this is the final answer. I'm just going to write that again, just to make it more clear. A squared plus 75a minus 125. Alright, and that is the final answer to this problem right here. Thank you for watching. I hope you learned something. Stay tuned for more mathematical videos.